Good afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSE, MLR Institute of Technology. Today I am going to discuss about the topic basis of counting in discrete mathematics. So the overview of this topic is what is meant by basis of counting, what are the rules we have to follow for counting problems, and we will discuss some example for understanding those two rules. So first rule is called as a product rule. And another one is called as a sum rule. So there are two rules we are going to use in the case of counting problem. So for example, X is a set 1, 2, 3, 4. This is a set which contains some elements. Mod X denotes the number of elements in the set. That means 4. We are using two basic counting principles which are the basic building blocks in the case of all type of counting problems. The first principle says that the sum is its of two parts. One is a immediate sum, another one is a elementary sum. In the case of elementary sum and elementary product, elementary sum is called as a sum rule, elementary product is called as a product rule. In the case of sum rule, what it says that the principle of disjunctive counting, for example, S1 is one set and S2 is another set. The sum of all the set of elements is called as a principle of elementary sum, or it is called as a disjunctive counting. In the case of disjunctive counting, we need to add all the set of elements as a single set. So by using the operator called plus, that's why it is called as a sum rule. Suppose for example, we are going to discuss about one example how the sum rule can be implemented. If two distinguishable dice are rolled, okay, there are two dice. These two are distinguishable. Distinguishable means, so that is a 1, 2 and 2, 1 are same. Distinguishable means, so 1, 2 and 2, 1 are same. 1, 3 and 3, 1 are same. That means first die can show 1 on the die and second die shows 3. 1, 3, 3, 1 are different. 1, 3 and 3, 1 are different. Then we can say that it is a indistinguishable. In the case of distinguishable means 1, 3 and 3, 1 both are same. Distinguishable means 1, 3 and 3, 1 are same. So, two distinguishable dice are rolled. Then how many ways can we get a sum of 4 or 8? That is the first example. Second example, how many ways we can get even sum? So, first of all, two distinguishable dice are rolled. So, in the case of two distinguishable, how to get 4? What are the possibilities? It is a distinguishable, then automatically 1, 3 and 3, 1 both are different. In case of indistinguishable, 1, 3, 3, 1 can be same. So, first one is a 1, 3. That is 4, 1 and 3. First die can show 1, second die can show 3. 1 plus 3 will get sum as 4. 2, 2. 2, 2. That means reverse also 2, 2, no need to write once again. And 3, 1. These are the three possibilities. If two distinguishable dice are rolled, we are going to get a sum of 4 is 3. Total number of elements are 3. Next, likewise, there are 5 ways to get a sum of 8. 4 or 8. 4 will get 3 possibilities. How to get 8? So, 2, 6 is one possibility. Maximum number of values in the die is 6 only. Maximum 6 only. 2, 6 is 2 plus 6, 8. 3 plus 5 is also 8. 4 plus 4. And in the case of distinguishable, so 5, 3 and 3, 5 are different. So, 3, 5 is also considered as a one element. Again, 6, 2. How many possibilities to get the sum as 8? So, there is a 5 possibilities. So, what is the first problem can say that how many ways we can get a sum of 4 or 8? 4 is 3 ways, or means you can use disjunction, that is plus. And how many ways we can get a sum of 8? 5. 3 plus 5, that is 8. That means to get the sum of 4 or 8, there are 8 ways. That is using the sum rule. Next, how many ways we can get even sum? In the case of dice, what are the even numbers? 2 is even number, 4 is an even number, 6 as even number. To get 2, 4, 6, what are the possibilities? Okay, 2, 4, 6 and also 8. Total, so that is a 1, 2, 3, 4, 6. These are the values that are present in the dice. If you combine those two values, we'll get, so 6 means maximum 12. 8, 10, 12. Up to 12, what are the even numbers? 2, 4, 6, 8, 10, 12. These are the even number. How many ways we can get the sum of 2 or 4, 6 or 8 or 10 or 12? So, we already know that 2 means 1, 1. That is only one possibility. That is 1, 1. How to get to 4? That just now we already done. That is 1, 3, 2, 2, 1, 1. 3, 1. That is 3 possibilities. Next, how many ways we can get the sum of 6? That is 2, 4. Then 4, 2. 3, 3. Then 1, 5. 5, 1. So, total 5 possibilities to get the sum of 6. Then, how many ways we can get the sum of 8? Just now we have done, that is a 2, 6, 3, 5, 4, 4, 5, 3, 6. Total 5 ways. Total 5 ways. How many ways we can get a sum of 10? That means, so that is 3, 4, 6, that is 10. 4, 6, 6, 4, then 5, 5. How many ways? There are 3 ways. There are 3 ways. How many ways we can get to 12? Only one possibility, that is 6, 6. That is 1. Then, according to the sum rule, we can add those values. 2, to get sum 2, there are 1 way. To get sum 4, there are 3 ways. To get sum 6, there are 5 ways. To get 8, then 5 possibilities, 10, 3 possibilities, 12. So, total adding all these values will get 18 ways to get an even sum in the case of 2 distinguishable dice. Now, consider second example. If 2 indistinguishable, in the case of indistinguishable, 1, 3, 3, 1 is considered as only one event. But in the case of distinguishable, these two considered as a 2 separate event. In case of indistinguishable, these two are considered as a single event. Then, how many ways can we get a sum of 4 or 8? How many ways we can get an even sum? First, we'll discuss about what are the possibilities to get a sum of 4. In the case of dice are identical, the outcomes are A, B, B, A cannot be differentiated. That means A, B and B, A both are same. So, how many ways we can get a sum of 4? That means 1, 3 or it is a 2, 2. But don't write 3, 1 because it is a indistinguishable dice. In the case of indistinguishable dice, A, B and B, A both are same. You can write the event only once but not twice. That is a 1, 3. Again another one is 2, 2. That is two possibilities. Next, how many ways we can get a sum of 8? That means 2, 6. One possibility. Don't write 6, 2 because it is a indistinguishable. 6, 2. Then 3, 5, 4, 4. There are how many ways? 3. Total, how many ways we can get a sum of 4 or 8? That is a 2 plus 3, that is equal to 5 ways to get the sum of 4 or 8. In the same way, how many ways we can get the even sum? What are the even numbers up to 12? That is a 2, 4, 6, 8, 10 or 12. Then, how many ways we can get 2? That is a, first one is 2. To get 2, 1, 1. Only one possibility. So, how many ways we can get 4? That is just now written 1, 3, 2, 2. That is 2 ways. Next, how many ways we can get 6? 6 means 2, 4 and then 3, 3. Then 1, 5. Don't write 5, 1, 4, 2 because that is a different. So, that means 1, 5, 3, 3, 2, 4 will get 3 ways to get a sum of 6. Next, how many ways we can get 8? 3 ways. 2, 6, 3, 5, 4, 4. That is 3 ways. Next, how many ways we can get a sum of 10? That is only 1. That is 5, 5. Then, after that 4, 6. Don't write 6, 4 because it is indistinguishable. There are 2 ways. 12, 6 only. So total how many ways we can get a sum of even sum, that is 1 plus 2 plus 3 plus 2 plus 1, total 12 ways we are going to get them. So number of ways to get an even sum. Then coming to the product rule. In the case of product rule, we have to multiply. But in the case of sum rule, we can add the set of events S1, S2, S3. So S1, what is S1? How many ways the particular even sum is happened? How many ways the particular S2 is happened? The total number of events will be summed together. That is nothing but a sum rule. But in the case of even product rule, if E1 is one event, E2 is one event, and so on, En can happen in how many ways? E1, E2, En ways. According to the product rule, we can say that so the particular event, the sequence of events is happened in E1 into E2 into E3 and so on, En ways. What is the difference between sum rule and product rule? In the case of sum rule, just we can add all those events and sum up together to get the product. How many ways we can get the particular event. But in the case of product rule, we have to multiply the events because E1 is happened in E1 ways. E2 is happened in E2 ways. E3 is happened in E3 ways. So according to the product rule, we have to multiply all the events and get the final product. That is the final value of how many ways the particular event is happened. Let us discuss one example. If two distinguishable dice are rolled, in how many ways they can fall? So the first die can fall in how many ways? First time we can get 1, second time 2, third time 3, fourth time 4, fifth time 5, sixth time 6 ways. And the second die also will be fall in 6 ways. That is 1, 2, 3, 4, 5, 6. That means first one is possible. The first one possibility is 6 ways and second one is possible is 6 ways. The first event is happened in 6 ways. Second event is happened in 6 ways. Total 6 into 6, 36 ways we will get an event. So if two distinguishable dice are rolled, in 36 ways they can fall. First time we can fall, we'll get 1, 1 maybe, or 1, 2, 1, 3, 1, 4, whatever it may be. But according to the product rule, there are 36 ways we are going to get the number of possible outcomes. Second example, if 5 distinguishable dice are rolled, 5 distinguishable rolls, how many possible outcomes are there? First die 6 ways, second die again 6 ways, third die again 6 ways, again fourth die 6 into 6 into 6. That means total 6 to the power of 5. So 6 to the power of 5 ways the particular event is happened. One event 6 ways, two events 6 into 6, 36. Like that 5 distinguishable dice are rolled, will get the outcome in 6 to the power of 5 ways. 6 to the power of 5 ways we can get the possible outcome. And consider one more example. In how many ways can we draw an ace or king? Ace or king. So that means in the case of 52 deck of cards, there is a description. So in the case of standard, there is a 13 cards. There are 4 suits, okay. Total 52 cards are present in a deck of cards. Out of 52, there are 4 suits. That means hearts, clubs, spades and diamonds. Each suit have 13 cards. That means 13 hearts, 13 clubs, 13 spades, 13 diamonds. That is 52. So what are the 13 cards means ace, then 2, 3, 4, 5, 6, 8, 9, 10, jaw, king and queen. So entire card, total entire deck has 52 cards each. That means 13 hearts, 13 clubs, 13 spades and 13 diamonds. According to the first example, in how many ways we can draw ace or king? How many aces are there? In the case of heart, ace is there. In the case of club, ace is there. In the case of spade, ace is there. In diamond also ace is there. There are 4 ways. Next, how many kings are there? Kings is also 4. For each case of card, there is a king is there. That is 4. 4 kings are there. Ace or king means or is there. If it is or is there, use the plus. If it is and is present, use multiplication. Ace or king, ace can be drawn in 4 ways and king can also be drawn in 4 ways. 4 plus 4 is equal to 8 ways we can get the So ace or king. Next, a numbered chord through to 10. How many numbered chords are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 chords. So that is 4, 5, 9 chords. Numbered chords are 9. There are 9 numbered chords, remaining ace, jack, king, queen. So how many ways we can get a numbered chord 2 to 10? That means, so there is each 13 chords, there is a 9 numbers chords are there. How many deck of chords? 52. So that means we are going to get 4 of pair. So a numbered chord 2 to 10 is 9 into 4. That is 36 ways we can get the numbered chord. A numbered chord or king. Numbered chord is 36. King you can choose it from 4. Total 40 ways we can draw the numbered chord, or it is a numbered chord, or it is a king. Total 40 ways. So, I told that sum rule is also called as a disjunctive counting, principle of disjunctive counting. Now, let us consider one more example. How many different plates can be manufactured if the repetition of letters and digits are repeated? If the letters and digits are repeated. So, total, how many number of letters are there? In English, there are 26 letters are there. That is from A to Z. Then how many digits are there? That is 0 to 9 means 10 digits. That is 10 digits. 0 to 9, 10 digits. So how many different plates can be manufactured if the repetition of letters and digits are allowed? Digits are allowed. That means there is a 3 letters. Okay, in the case of plates, that is nothing but a 3 letters numbered chord. In the case of plate, chord number where the plate is there. So there is a 3 numbers. So 3 numbers means each and every one can be manufactured by using 26 ways. And what about 3 digits? 3 digits means each and every number consisting of 10 digits. That is a 10, 10, 10. That means 26 to the power of 3 into 10 to the power of 3. Suppose if it is a number plate is manufactured with 3 letters and 3 digits. 3 letters and 3 digits. So 3 letters can be repeated. That means the repetition is allowed means you can write 26. Suppose you are using the plate A, Z, A like this. A may be repeated. A may be repeated. After that 3 digits, 111. This is a numbered plate chord. So repetition allows means you can use the A one more time. That is a repetition. How many plates are possible if only letters can be repeated? Only letters can be repeated means digits cannot be repeated. Digits cannot be repeated. Suppose number plate consisting of 3 letters and 4 digits. 3 letters and 4 digits. 3 letters means that is a 26 letters. Here it is not specifically, it is not defined whether the letters digits are allowed. Letters can be repeated or not. If only letters repeated means digits cannot be repeated. So you can write 26 3 times because repetition is allowed for the letters. But digits cannot be repeated means suppose if you use 9, don't use the 9 in the second place because repetition is not allowed. So automatically the number of letters will be decreased. Then we'll get 10 into 9 into 8 into 7. That means 26 to the power of 3 into, then we'll multiply 10 into 9 into 8 into 7. That many plates are possible if only letters are repeated. Next, how many ways are possible if the digits can be repeated? Means letters cannot be repeated. So that manufacturing plate consisting of 3 letters and 4 digits. 3 letters and 4 digits. In the case of 3 letters, digits can be repeated means letters cannot be repeated means first one use A. Don't use A again. So automatically one letter will be decreased. Then the number of letters are 25. Don't use A, B again. So root letters are decreased means next one consisting of only 24 possibility. But digits can be repeated means you can use the same digit in 4 places. That is 4 places you can use the same digit. That is a product rule and also sum rule. So now we'll discuss 2-3 more examples for better understanding of sum rule and product rule. How many subdivision house numbers can be issued using 1 letter and 3 digits? 1 letter and then 3 digits. So these are the letters. and these are the digits. If nothing is given, then repetition is allowed. If repetition is allowed, so that means say house number is consisting of one letter and three digits. One letter means you can use A, B, C like that, and digits are 1, 2, 3, B 1, 2, 3, and C 1, 2, 3. How many ways we can arrange the letters? 26 ways. 26 ways, because there are 26 English alphabets is there. That's why we can arrange the first letter in 26 ways into. So digits, you cannot specify anything, so digits may be repeated. So 10 into 10 into 10, that is equal to 26 into 10 to the power of 3. These many ways we can divide we can constructing the house number. That means that many possibilities are there to to design the house numbers. Next, second example, how many ways you choose one from each 10 teachers, send staff and 20 students. Okay, that means there are 20 students are there, but you have to choose one for each teacher. Okay, one for each teacher. 10 teachers are there, 7 staff members are there, and 20 students are there. So 20 students will select 10 teachers, and 20 students may select 7 staff. 20 students may select 1 staff. So how many ways we can choose 10 teachers? 10 teachers can be selected in 10 ways. Then 7 staff will be selected in 7 ways, and 20 students are selected in 20 ways. Then we can use 10 teachers, 7 staff. This is 10 plus 7 into 20. That many ways we can choose the value. Next, how many 4-digit numbers can be formed from the digits 1, 2, 3, 4 if the digits cannot be repeated? 4-digit number. The number consisting of 4 digits. It is a 4-digit number. In the case of 4-digit number, we can form the digit with the help of 1, 2, 3, 4, 5. Digits cannot be repeated means 5 digit, 1, 2, 3, 4. So 5s can be used in 5 ways. Then, so not be repeated means next one is 5 is already used, remaining 4. 4. Next, 4 is already used, don't use the same digit again. Again 3 ways. After the 3 is already used, you can use 2. That means 5 into 4 into 3 into 2. 5 4 is a 20, 23 is a 60, 60 into 2, 120 ways. 120 ways we can form the 4-digit number from the digits of 1, 2, 3, 4 without repetition. Next, consider 2 more examples. If you have 5 t-shirts, the t-shirts are 5, and 4 pairs of pants and 3 pairs of shoes. In how many different ways can you choose one of each way to wear as an outfit? So 5 t-shirts you can wear in 5 ways. Then that means second one is 3 pair of shoes can be wear it in 3 ways, and 4 pair of pants can be wear it in 4 ways. Total how many ways you can choose any one of the wear as an output means 5 into 3 into 4, that is equal to, so 60 ways you can choose. 60 ways you can choose the different types of outfit. That may be t-shirt, that may be 4 pairs of pants, you can choose it in 4 ways, and 3 pairs of shoes can be used it in 3 ways. Total number of ways that is 5 into 3 into 4, that is 60 ways are possible to wear the output. Next, if a restaurant offers 3 types of soups and 5 main courses and 2 dessert, how many different ways can a person choose 1 soup, 1 main course and 1 dessert? So 3 types of soups can be used in 3 ways, and 5 main courses can be used in 5 ways, and 2 desserts can be used in 2 ways. Total number of ways are 30 ways. We can use the dessert for a meal. 30 ways. Next, a student can choose 1 subject from 4 science selectives, 1 from 3 language options, and 1 from 2 sports activities. How many different combinations? 1 subject, 4 science selective. 4 science selectives are selected in 4 ways. And then 3 language options can be selected in 3 ways. and 2 sports, that means 4 into 3 into 2. So that is a 12 to 24 ways we can choose the option. There is a 24 ways we can choose the options. So what we have discussed means there are 2 basic counting principles in the case of discrete mathematics. One is a sum rule. Another one is a product rule. So sum rule is also called as a disjunctive principle of disjunctive or disjunctive counting. By applying the sum rules, we can add all the events, sum up together and find the total number of ways. For sum rule, we can use plus is the operator. In the case of product rule, we can use multiplication as an operator to find how many ways the particular event is happened. So the total number of ways is we have to multiply all the number of events to get the final outcome, and we can understanding those basics of counting with the help of examples. Thank you.